So homework 26 starts off with the sum and difference identities, problem type 1. And so it wants us to find the exact value of sine of 105. And what we want to do is split it up either into a sum or a difference of the common ones that we know, like 45 degrees, 30 degrees, 60 degrees, and separate it and then use our formula. So I'm going to flip over here to Linda's note sheet. Linda's note sheet says, here are your sum and difference formulas. A sine of A plus B is the sine of A, cosine of B plus cosine of A, sine of B, and so forth, all listed there. I'm going to keep my paper handy because I don't have these memorized. At one time I probably did, but I don't anymore. So that we have our sum and difference formulas. You might want to just print out my notes or explain. Also on Alex, if you just go into the dictionary and type in sum and difference, it's going to bring you up a list with your different identities there that you can print out. The other thing you're going to want to keep handy is this handy dandy table. And I didn't put it on every single note sheet, but I put it on quite a few of your note sheets. But this is your common. The sine of 30 degrees is 1/2, cosine square root of 3 over 2. All of those, you're going to want to have that piece of paper handy also. Again, I'm just going to keep it here because that way I don't have to keep flipping back and forth and looking at the chart. I'm going to assume you can look at the chart while I'm looking at my chart. So, over back here, I want to do the exact value of the sine of 105. So if I figure out the sine of 105, I see that it ends in a 5. I would probably subtract the 45 off of there first to see if 45 minus 105 is anything that's nice. And it happens to be 60. So I'm going to separate this into the sine of 60 plus 45, or 45 plus 60, whichever order you want to put that in. So using the sine of A plus B, I'm going to have the sine of A cosine of B plus cosine of A sine of B. So sine of A plus B, there's my formula. So I'm going to do the sine of 60 cosine of 45 plus cosine of 60 sine of 45. So this is where I want to grab my other piece of paper with my table in and look up what is the sine of 60. The sine of 60 is square root of 3 over 2. Cosine of 45 is square root of 2 over 2. Cosine of 60 is 1/2. And the sine of 45 is square root of 2 over 2. So we would get the square root of 6 over 4 plus the square root of 2 over 4. And then just combining that into one answer then, I would have the square root of 6 plus the square root of 2 all over 4 for my answer. So on the next one, if I'm finding the cosine of pi over 12, I want to think of that as 1/12. And how can I get 1/12? Well, I can get 1/12 if I take 1/3 minus 1/4, because if I have my common denominator, I would have 4/12 minus 3/12, which is 1/12. So I'm going to say that this is the cosine of pi over 3 minus pi over 4. Pi over 3 and pi over 4 are some of our common angles that we have. And so I'm going to do the cosine of A minus B, and if I look at the formula there, it says I'm going to take the cosine of A, cosine of B, and I'm going to add the sine of A, sine of B. So I'm going to do the cosine of pi over 3, cosine of pi over 4, plus the sine of pi over 3, and the sine of pi over 4. So again, looking at my table, that one that tells me what all of my angles, etc., cosine of pi over 3 is 1/2. Cosine of pi over 4, square root of 2 over 2, plus sine of pi over 3, square root of 3 over 2, and sine of pi over 4, square root of 2 over 2. So we're going to get the square root of 2 over 4 plus the square root of 6 over 4. So our answer, square root of 2 plus square root of 6 all over 4. Forgot if I had to check, see if I hit record. Cosine of 75. So again, if I think about 75, 45 plus 30 is 75. So I'm going to say I'm going to do the cosine of 45 plus 30. And then I'm going to use my formula for the cosine of A plus B. Looks sort of like the cosine of A minus B. We're just going to change a sign in there. So we're going to take the cosine of A, cosine of B, minus the sine of A, sine of B. And so, cosine of 45, cosine of 30, minus sine of 45, sine of 30. Cosine of 45, that's our square root of 2 over 2. We've done that a few times. Cosine of 30, square root of 3 over 2. Minus the sine of 45 is square root of 2 over 2. Sine of 30 is 1/2. So we're getting the square root of 6 over 4 minus the square root of 2 over 4. So our answer, whoa, that was crazy. I'm just going to leave that there for a minute. We have the square root of 6 minus the square root of 2 all over 4. See if I click that, if that, nope, wants to close my ink. There it is, got rid of that little message. So, keep your formulas handy, keep the sheet with your common angle, sine, cosine. That's all you're probably going to have to use on this one much. Handy, so you can look those up, and then you just simplify, get your answer. Alright, sum and difference identities, problem type 2. Again, we're going to need the sum and difference identities as well as our table. If I hop over here to my note sheets, sum and difference identities, when you have the sine ones, you have sine, cosine, sine, cosine. For the cosine ones, they start off with cosine, 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 cosine. Tangent ones are pretty obvious, but you'll want to keep those handy. Again, I'm just going to have them on my paper here so I don't have to flip back and forth to the screen. Also, again, on my notes, you're going to want to have the table here where you can look up what the sine, cosine, tangent of your angles are. And so if you have that piece of paper handy, I also have it on the bottom of this note sheet page, but I don't have it on every one of them. So you should have that paper somewhere because we've used it a lot. So you'll want to have that paper handy also. So if I go back over here, first one wants us to use the sum or difference formula to find the exact value of the following. Starts off with cosine, cosine. I know that's my cosine identity. This one has the minus sign in between, and so if you look at your sum and difference identities, this is going to be the cosine of A plus B. And so I'm just going to say, okay, I'm going to do the cosine of 3 pi over 5 plus 7 pi over 30. And then I'm going to find my common denominator and do my adding and subtracting here. So if it's over 30, 5 goes into 30 6 times, I would have 18 pi plus 7 pi, which is 25 pi over 30. And then if I divide those by 5, I would have 5 pi over 6. So cosine of 5 pi over 6. At that point in time, you're going to look up in your table what is the cosine of 5 pi over 6? So again, if you have this table handy, 5 pi over 6, my cosine is negative square root of 3 over 2. And it probably erased everything, which it did. Cosine of 5 pi over 6 is negative square root of 3 over 2. And so that's going to be your answer. And so again, I won't jump back and forth because when I do that, it wants to erase my board. But keep those papers handy. If we look at the next one there. The next one says the sine of 3 pi over 4 cosine of 7 pi over 12. Because it starts with sine, cosine, I know it's one of my two sine ones. Since there's a minus sign in there, if you look at your things, that is going to be the a minus b. So again, we're going to do the sine of 3 pi over 4 minus 7 pi over 12. Since we're working with our fractions, we'll find our common denominator, which is 12. 4 goes into 12 3 times, so I'm going to have 9 pi minus 7 pi, which is 2 pi, over 12, which would give me pi over 6. So I'm going to find the sine of pi over 6. So again, I'm just going to look up in the table, and if you look up the sine of pi over 6, should be 1/2. So 1/2 is going to be your answer. And the next one starts with cosine, cosine. So I know it's my cosine one. This one has the plus in there. If it has the plus in there, it's going to be the a minus b. So I'm going to do the cosine of 5 pi over 7 minus 8 pi over 21. My common denominator is 21. 7 goes in there. 3 times 5 is 15 pi. Minus 8 pi gives me 7 pi. And of course I can reduce that down, so I'm going to get pi over 3. So I'm going to go look up in my table the cosine of pi over 3. If you look for the cosine of pi over 3, you should see that your answer is 1/2. So again, back over here on that table, pi over 3, if I look for the cosine, there it is, 1/2. You probably can't read it on the video, but keep that table handy. You're going to need it for a lot of problems. Some of the note pages I have it on, but I didn't put it on every note page, so you'll want to find that sheet. Make sure you have it handy when you're working on these. Alright, so 7, 8, 9, again we're doing the sum and difference identities. This is problem type 3. Sum and difference identities, again, are right here. For example, if I have the sine of a plus b, I have the sine of a cosine of b plus cosine of a sine of b. You're going to want to keep that handy while you do these problems. I'm going to write them on my paper, and so I don't have to flip back and forth, but you want to have that list handy as we work out these problems. I'm going to go over here. On these ones, we're going to draw our reference triangles. So first of all, we have the cosine of 4/5 in quadrant 4. So in quadrant 4, the cosine is going to be the adjacent over the hypotenuse, so I'm going to have 4 over 5. Using my Pythagorean theorem, a squared plus b squared equals c squared, so 4 squared plus b squared equals 5 squared. That means I'm going to subtract my 4 squared. 25 minus 16 is 9. Square root of 9 is going to give me 3. This is going down, so it's going to end up being a negative 3. My other angle is in quadrant 3. Tangent is going to be the opposite over the adjacent. Here I'm going to have a negative over a negative, so my opposite side is going to be negative 3. My adjacent side is negative 4. And if I use my Pythagorean theorem, negative 3 squared plus negative 4 squared gives me 9 plus 16, which is 25. And the square root of 25 is 5. And we know the hypotenuse is going to be 5 then.
Hopefully you're really good by now drawing those reference triangles. So now if we look back at our formula for cosine of alpha plus beta, I'm going to have the cosine of alpha cosine of beta. That's a plus, so this will be minus sine of alpha sine of beta. So cosine of alpha, that was easy. They already told us it was 4/5. Cosine of beta, cosine would be the adjacent over the hypotenuse, so negative 4/5. Minus the sine of alpha. The sine of alpha is up here, negative 3/5, opposite over adjacent, or opposite over hypotenuse, excuse me, opposite over hypotenuse. And the sine of beta, opposite over hypotenuse, negative 3/5 again. So here we are going to have negative 16 over 25 minus, that's going to be positive 9 over 25. Negative 16 minus 9 would give me negative 25 over 25, which simplifies into negative 1 then. So my answer, negative 1. Number 8, we're doing sine of alpha minus beta. Alpha is going to be 5/13. It's in quadrant 2. So quadrant 2, my sine is going to be the opposite over the hypotenuse. So 5 and 13. So 5 squared plus b squared equals 13 squared. So I'd have to subtract my 5 squared. 169. 169 minus 25. 4 would be 144. Square root of 144 is 12, but it's going backwards, so that's got to be a negative 12 there. So the other one's in quadrant 3. So quadrant 3 would be back here. It's my cosine. My cosine is the adjacent over the hypotenuse. So my adjacent is negative 15. My hypotenuse is 17. And so negative 15 squared plus b squared equals 17 squared. Negative 15 squared is going to be 225. Well, so 225. 17 squared is going to be 289. So if I subtract my 225, I get 64. Square root of that would be 8. I'm going down, so I have to have a negative 8 there. So I've got my two reference triangles. Now I need to worry about doing the sine of alpha minus beta. That's going to be the sine of alpha cosine of beta minus, and then I'm going to have, I'm going to look that up there, cosine of alpha, switch that around, and sine of beta then. So cosine of alpha, or sine of alpha, cosine of beta, cosine of alpha, sine of beta. So looking here, sine of alpha was the 5/13. Cosine of beta, well, cosine of beta, negative 15/17. Minus cosine of alpha would be negative 12/13. Sine of beta is going to be negative 8/17. And so we have to multiply that out. 5 times negative 15 would be negative 7, or negative 17, negative 75. 13 times 17 is 221. Minus, here we have a negative times a negative. 12 times 8 is 96. And 13 times 17 again is 221. So we're going to take negative 75 minus 96. We get negative 171 over 221 then. And that's going to be my answer. Number 9. Same kind of thing. Doing the sine of alpha plus beta. Starting off with my first angle in quadrant 4. My cosine is the adjacent over the hypotenuse. So 5 over 13. So 5 squared plus b squared equals 13 squared. I'm going to subtract my 5 squared. 169 minus 25 was 144. Square root of 144 was 12. It's going down, so it's got to be negative 12, right? And on the other one, we are in quadrant 2. Quadrant 2, we are doing the sine, so opposite over hypotenuse. So 12 over 13. So we're going to say 12 squared plus b squared equals 13 squared. 144, 169, so subtract my 144. Gives me 25. Square root of 25 is 5, but it's going backwards, so it's got to be a negative 5. Got my two reference triangles. I got to do my sine of alpha plus beta. So I'm going to have the sine of alpha, cosine of beta, plus cosine of alpha, sine of beta. If I look up my formula. So sine of alpha, negative 12/13. Cosine of beta, negative 5/13. Cosine of alpha, 5/13. Sine of beta, 12/13. So negative 12 times negative 5 would be 60. 13 times 13 is 169. Plus 5 times 12 again is 60 over 169. 60 plus 60 is 120 over 169. So 120 over 169 would be the sine of alpha plus beta. (10, 11, and 12), we're back to doing proving trigonometric identities. This time we're going to add the sum and difference properties. So you're going to want a couple different sets of notes. First of all, you want the one that has a whole bunch of your identities. We've got our reciprocal identities, such as the sine of u is 1 over the cosecant. Our quotient ones, where we take tangent and cotangent and put them in terms of sine and cosine. The Pythagorean identities. We haven't talked much about the odd and even ones, but we occasionally use those. So mainly those first three. Then we also want the sum and difference identities, because we're going to turn these ones into these ones. And so we'll end up with something like sine of A cosine of B plus cosine of A sine of B, and turn it into sine of A plus B. So you'll want that sheet with your sum and difference identities, and your other sheet with the rest of your identities to use for reference. And if I can get back to our question. So we are going to prove our identity. We're going to put it in terms of the cosine of x plus y and the sine of x minus y. And if you look at those identities, they're all in terms of sine and cosine. So I want to change my tangent and cotangents into terms of sine and cosine. And so I'm going to use those quotient identities to do that. You can do it all at once since you're using the same one. And so for cotangent, I'm going to have cosine over sine. So I'm going to have the cosine of x over the sine of x times the cosine of y over the sine of y minus 1 all over cotangent again. So cosine of y sine of y minus cosine of x over the sine of x, using my quotient identity to replace all of my cotangents with cosine over sine. The next step there, I want to basically make this into one fraction this into one fraction by using my common denominator, sine of x, sine of y. Same thing here, sine of x, sine of y. So I'm just going to do some algebra. So in this case, I'm going to have cosine of x, cosine of y, minus, and I'm going to have to take this times the sine of x, sine of y. Sine of x, sine of y. That's going to put that all over sine of x, sine of y. On the bottom, I'm going to have a really big fraction. I'm going to end up taking this one times the sine of x, this one times the sine of y. So I'm going to have the sine of x, cosine of y, minus cosine of x, x, sine of y, over my common denominator, sine of x, sine of y. Doing algebra. Again, I'm writing too big, so it never ever fits on my thing. But my next step, I have one fraction divided by another fraction. I can invert and multiply. So this is going to be sine of x, sine of y, over sine of x, cosine of y, minus cosine of x, sine of y. And then I'm going to be able to cancel that out. And so I'm going to end up with this on top, this on the bottom. So cosine of x, cosine of y, minus sine of x, sine of y, over sine of x, cosine of y, minus cosine of x, sine of y. And that again, writing that right on top of my other junk, just doing algebra again. So now what you should notice here is that I have cosine of x, cosine of y, minus sine of x, sine of y, which is your cosine of x plus y. And on the bottom we have sine of x, cosine of y, minus cosine of x, sine of y, which is your sine of x minus y. And that is using the sum and difference identities. So I should have 4 steps to that problem. First of all, replacing your cotangent using your quotient identities, doing algebra to find your common denominator, doing algebra again when you multiply by the reciprocal to get rid of those, and then replacing with the sum and difference identities, and now you have it solved. So number 11, we want to prove the identity. This time we have the cosine of x minus pi over 4 minus the cosine of x plus pi over 4. So we're going to use the cosine of a minus b, the cosine of a plus b, and then simplify to see if we can figure out what we're doing. So if we go ahead and do that, if I have the cosine of x minus b, I'm going to take the cosine of x, cosine of pi over 4, plus sine of x, sine of pi over 4. There's my difference. Then I'm going to have minus, if I have a plus b, I'm going to have the cosine of x, cosine of pi over 4, and that's going to be minus cosine of x, cosine, that should be sine, sine of x, and sine of pi over 4. That's using our sum and difference identities, as we always have to pick out which property we're using. So just expanding that using our sum and difference. So now we're going to substitute in here, or simplify here. Let's see here. We are going to do cosine of x, cosine of pi over 4, minus cosine of x, cosine of pi over 4. So those are going to cancel out. When I subtract a negative, I end up adding, so I'm going to have 2 of those. So I have 2 sine of x, sine of pi over 4, just doing my algebra, subtracting my 2 expressions. Then I'm going to look up at my table. In my table, I have the sine of pi over 4. If I look at the sine of pi over 4, it's square root of 2 over 2. So I have 2 sine of x square root of 2 over 2. And they're going to call that step evaluation. We haven't used that yet. Yep, I can even spell it. Evaluation. So if I have to look up the table and find what the sine or cosine of an angle is, they're going to call that evaluation. Now in this case, I can cancel this out. Move that to the front. I have square root of 2 sine of x. And again, that's just using algebra. And I have my identity proven. Number 12, we want to prove our identity. Again, we start with the sine of x plus y. So we're going to go ahead and substitute in for the sine of x plus y. So I'm going to have the sine of x cosine of y plus cosine of x sine of y over my cosine of x sine of y. That's using my sum and difference identities, just substituting in for the sine of x plus y. Next thing I'm going to do is just separate that into two separate fractions. So I'm going to have the sine of x cosine of y over the cosine of x sine of y plus cosine of x sine of y over cosine of x sine of y. So that's just doing algebra, just breaking it down into two separate parts. And again, I'm just going to do some more algebra here because if you notice, I've got the exact same thing over itself, so I can change that into 1. So I'm going to have the sine of x cosine of y over cosine of x sine of y plus 1. Algebra. Now notice that I have sine of x over cosine of x, which is the tangent, cosine of y over the sine of y, which is the cotangent. Those are my quotient identities. So sine over cosine would make that tangent of x. Cosine over sine makes that cotangent of y. And that's using my quotient identities. And you can see that I've proven my identity. I ended up with tangent of x, cotangent of y, plus 1. (13, 14, and 15, we are doing the double angle identities. So again, if I go to my note sheets, my double angle identities, the sine of 2x is 2 sine of x cosine of x. Cosine of 2x, I actually have 3 different formulas. They're all Pythagorean identities, which are switched around. So cosine squared minus sine squared, if you like, 2 cosine squared minus 1, or 1 minus 2 sine of x, or sine squared of x. Doesn't matter which one of those 3 you use, you should get the answer with any one of those 3 formulas. Tangent of 2x is 2 tangent of x over 1 minus the tangent squared of x. So again, you're going to want to keep these identities handy. I'm going to write them on my paper so I don't have to flip back and forth all the time. And so look back at those while we're working our problems out. So here, if we go back to find the sine of 2x, cosine of 2x, and tangent of 2x, if we know the cosine of x is negative 4/5 and x terminates in quadrant 3. Drawing our reference triangle like we get to do a lot. Over here in quadrant 3, we know that cosine is adjacent over hypotenuse, so we have negative 4 and 5. We need to find our other side. Negative 4 squared plus b squared equals 5 squared. This is 16, this is 25. We subtract, we get 9. The square root of 9 is 3. This is going down, so I would have a negative 3 for the length of that side. So, using 3 different formulas, starting off with the sine of 2x. If you look that up on your paper, sine of 2x is 2 sine of x cosine of x. So I'm going to have 2 times the sine, which is negative 3/5, times the cosine, which is negative 4/5. And then I'm just going to multiply that out. So I am going to get 24 over 25, and it's going to be positive. And that is going to be my first answer for the sine of 2x. Then I am going to do the cosine of 2x. Again, you can use any one of the 3 formulas. I'm going to use cosine squared minus sine squared. So, the cosine was negative 4/5. Take my negative 4/5 and square it, minus my sine, which was negative 3/5. Got to square that. So I am going to here get 16/25 minus 9/25. And if I subtract 16 minus 9, I get 7/25. And that's my answer for cosine of 2x. Lastly, we're going to do tangent. And if you look up on your paper, we are going to have 2 tangent of x over 1 minus tangent squared of x for our formula. So tangent is going to be opposite over adjacent. Negative 3 over a negative 4 would be a positive 3/4. So I am going to have 2 times 3/4 over 1 minus 3/4 squared. So this is going to cancel. I'm going to get 3 over 2 on top. On the bottom, I'm going to have 1 minus 9/16, making my equivalent fraction. I'm going to have 16/16 minus 9/16, which is 7/16. So I have 3 over 2 over 7/16. I have to invert and multiply. So I'm going to multiply by 16/7. 2 goes in there 8 times. 3 times 8 is 24. 7ths then would be my answer when I simplify. Going crazy on me. Number 14 then, same kind of thing. Find the sine of 2x, cosine of 2x, and tangent of 2x if the tangent of x is negative 2, which means I have negative 2 over 1. Quadrant 4 is where we're at. So quadrant 4, we are going to have tangent, which is opposite over adjacent. So we're going to have negative 2 and 1 there for our 2 sides. And then we have to use our Pythagorean theorem. So 1 squared plus negative 2 squared. 1 plus 4 is 5. We're going to have the square root of 5 for our hypotenuse. And of course our hypotenuse is going to be a positive. Once we have our reference triangle, we can go ahead and find all our double angles. So sine of 2x is 2 sine of x. Cosine of x, so 2 times the sine. The sine is negative 2 over the square root of 5. And the cosine would be 1 over the square root of 5. Which means I am going to get negative 4. Here I'm going to get square root of 5 times the square root of 5, which is the square root of 25. And the square root of 25 is just 5. So I get negative 4/5. Cosine of 2x. Cosine of 2x, again, I'm just going to use cosine squared minus sine squared. You can try one of the other ones if you want. Cosine squared minus sine squared. And so my cosine was 1 over the square root of 5. And square that. minus negative 2 over the square root of 5. I've got to square that. So when I square this, I'm going to get 1. When I square the square root of 5, I just get a 5. Right? I get square root of 5 times square root of 5, which is square root of 25, which is just 5. Minus a negative 2 squared is 4. And again, when I square my square root of 5, I get 5. So I have 1/5 minus 4/5, which is negative 3/5. I need a little bit more room for my tangent, but I'll sneak it in there. Tangent of 2x. We said was 2 tangent of x over 1 minus tangent squared of x. So 2 times the tangent. The tangent was negative 2. It was negative 2 over 1, which is just negative 2. And 1 minus the tangent squared. So 2 times negative 2 would be negative 4. This is going to give me 1 minus a negative 2 squared is 4. So I get negative 4 over negative 3, which is a positive 4/3 for my tangent of 2x. I'm going to go ahead and move the board up so I have a little more writing room. I'm not way on the bottom. If it lets me. There we go, 15. So 15, we are in quadrant 3. So drawing my reference triangle over here in quadrant 3, the sine is the opposite over hypotenuse, so negative 5/13. So negative 5 squared plus b squared equals 13 squared. So that's 25, that's 169. If I subtract, I get 144. The square root of 144 is 12. That's going backwards, so I'm going to have a negative 12 for the length of my side in my reference triangle. So sine of 2x is 2 sine of x, cosine of x. So 2, the sine is negative 5/13. The cosine is negative 12/13. Multiplying all of that together, negative 10 times negative 12 would be positive 120. 13 times 13 is 169. So I get 120 over 169. Cosine of 2x. Again, I'm just going to use cosine squared minus sine squared, just because I like to use the same one. So cosine squared of x minus sine squared of x. My cosine is negative 12/13 squared. My sine, negative 5/13 squared. So this would give me 144 over 169 minus 25 over 169. And if I take 144 and I subtract 25, I get 119 over 169. And then lastly, the tangent of 2x. We're going to use 2 tangent of x over 1 minus tangent squared of x. Tangent, opposite over adjacent. I'm going to have a negative over a negative, so I'm going to use a positive 5/12. So 2 times 5/12 over 1 minus 5/12 squared. So in this case, the 2 and the 12 would reduce, so I get 5 over 6. On the bottom, 1 minus, this would give me 25 over 144. Making my equivalent fraction here, this would be 144 over 144. So 144 minus 25 is 1/19. So I'm going to have 5/6 over 1/19 over 144. I have to invert and multiply. So I'm going to multiply 144 over 119. I can reduce that a little bit. 6 goes into 144. 6 goes into 144 24 times. That went in there nicely. So I then have 5 times 24. 5 times 24 is 120 over my 119. So double angle identities there. 16, 17, and 18, again, we're doing the double angle identities. I'm going to bring them up again. So sine of 2x is 2 sine of x cosine of x. Cosine of 2x is cosine squared minus sine squared. 2 cosine squared minus 1, or 1 minus 2 sine squared. And tangent, 2 tangent of x, 1 minus tangent squared of x. These ones we're going to kind of go in reverse order, so they're going to look like this form, and we're going to put them into the double angle and simplify. So it's going to be pretty easy to do. And so if I pop back over here, we have cosine squared minus sine squared. So we know that's the cosine of 2x. So I'm going to do the cosine of 2 times 49 degrees. And so if I go ahead and multiply 2 times 49, I get 98. And so I get the cosine of 98 degrees. And that's all I'm going to do with that. Now this one's a little bit different because it sort of looks like my double angle formula, but kind of not, because I don't have the 2 in front of here. So what I have to do is I have to change my formula a little bit, and I have to go like this. I'm going to have 1/2 times 2, so those cancel out. Sine of 5 theta, cosine of 5 theta. So now this part is my double angle. So I'm still going to have the 1/2 in front, and this is going to be the sine of 2x, and x is going to be 5 theta. So I am going to have 1/2 sine of 10 theta. That almost looks like 10 theta. So my answer is going to be that. That's as far as I can simplify that. I can't take the half of this, so I'm just going to say 1/2 sine of 10 theta. So if I see that, I have to think of something I can substitute in so that it looks like my formula with the 2 in front of there. And the last one is again a cosine double angle. I have 2 cosine squared minus 1, which is going to be the cosine of 2x. So if I have the cosine of 2 times 28, and I just multiply that out, 2 times 28 is 56. So I get the cosine of 56 degrees, and that's all I'm going to do to simplify that. So that one's pretty easy to do since it follows my formula exactly.